Good day and welcome to these video lectures about Gauss-Seidel power flow calculation. And this time I will use Octave or Matlab application for the solution. Before we go to Octave calculation, I will explain first the details of the sample problem. We will start our sample problem using 3-bus system. So we have bus number 1, bus number 2, and bus number 3. And I will assign bus number 1 as slack bus number 2 as generator bus, and bus number 3 as load bus. These 3 buses are connected by transmission lines. We have line 1 with admittance of negative J10, line 2 with admittance of negative J15, and negative J5 for line 3. The other given values are, for slack bus, the voltage B1 is equal to 1.0 per unit, and the angle delta is equal to 0 degrees. For generator bus, the real power P2 is equal to 0.85, and the voltage P2 is equal to 0.99. And for load bus, the real power P3 is equal to negative 1.2, and the reactive power Q3 is equal to negative 0.7. We will define first the elements of the Y admittance. Since we have 3 bus, our admittance will be 3 by 3 matrix. Please note that I use an imaginary I instead of J because in Octave I will use an imaginary I, but it is the same. The numbering of the matrix are Y11, Y12, Y13, Y21, Y22, Y23, Y31, Y32, and Y33. Now let's define each element of the matrix. The admittance of line from bus 1 to bus 2 is Y12, which is negative 10I. But I write positive 10I because if you watch my previous video lectures, the mutual admittance is negative. So negative of negative 10I is positive 10I. Y13 is 15I and Y11 is negative 25I. Y11 is the self-admittance and it is the sum of mutual admittance which is negative 10I plus negative 15I is equal to negative 25I. Since it is a symmetric matrix, Y12 is equal to Y21, Y13 is equal to Y31, and Y23 is equal to Y32. So the remaining self-admittance for column 2 is negative 15I, and for the last row is negative 20I. Now, how many state variables do we have for 3-bus system? For every bus, we have 2 state variables, and these are voltage and angle. Therefore, the total state variables for 3-bus system is 6. In the table, the tabulation of parameters are given for each type of bus. We have bus number, type, state variables, and power injected. So for bus number 1, we have an slack bus with a given state variables of voltage which is equal to 1 per unit and each angle is 0 degrees. The power injected is unknown. So for Bus number 2, which is a generator bus, the voltage is 0.99 and the power injected is 0.85. For load bus, the state variables B and angle are unknown, and the given values of real power P is equal to negative 1.2 and the reactive power Q is negative 0.7. In solving power flow by Gauss-Seidel method, there are things to remember. Number one, if the bus is a generator bus, you need to solve for reactive power Q and voltage B. Number two, if the bus is a load bus, you need to solve only for voltage B. So this is the equation in solving the reactive power of bus K, which is QK. And this is the equation in solving the voltage of bus K, which is Bk. I think the details are complete. We will go to Octave Matlab software. Now we are here at Octave program window. Octave is a free version of Matlab. This is free to download. Okay, let's start with our script writing. I already write the specifications of our sample problem, wherein we have a 3-bus system where bus 1 is a slack bus 2 is a generator bus, and bus 3 is a load bus. Now we will define first the Y-bus elements or the Y-bus matrix. I will name it as Y. So we have negative 25i, 10i, and 15i. The second row, we have 10, negative 15, 5. 10i, negative 15i, and 5i. So for the last row, we have 15i, 5i, and 20i. 15i, 5i, negative 20i. Close bracket. Next is to define the known state variables. We have V1, it is equal to 1.0. V2 equal to V2 is 0.99. (0.99) E2 0.85. E2 0.85. P3 negative 1.2. P3 equals to negative 1.2. And we have Q3 negative 0.7. Q3 negative 0.7.
Maraming nabibili pa. Dahil kay Angeline. Bayad ito, ma. Kunan ko na lang picture, ma'am.
State variables.
So,
Next is to define the initial estimates of B3. B3 is equal to 1.0.
po, ma'am. May ano po, ma'am, may...
I already write here the equations or the record equations to solve our sample problem.
Po, po, ma'am,
So our record equation is Qk is equal to Bk summation of Yki times Bi times sine delta k minus delta n minus delta kn, where I is equal to 1 to n. And Bk is equal to 1 over Ykk times Pk minus Jqk divided by Bk conjugate minus summation of Yki times Bi, where I is equal to 1 to n, where I is not equal to k. As I said earlier, that when the bus is a generator bus, we need to solve for reactive power Q and voltage V. So in our problem, bus 2 is a generator bus. So we will write first the equation of reactive power Q2 is equal to absolute P2 times absolute Y 2, 1 times absolute B1 times sine angle of B2 minus angle of Y2, comma 1 minus angle of B1 close parenthesis. So we go to the next class, absolute to, or it's better to copy the first one. E2 Y22 solar E2 main angle B times angle Y22 is angle E2. We need another copy. The absolute B2 Y23 3 solar 3 sin angle E2 Y23 angle E3 column. So we need also to write the equation for B2 is equal to 1 over Y 4 comma 2 times B2 minus U2 times I divided by conjugate of B2 minus Y2 comma 1 times B1 plus Y2 3 times B3. close parenthesis, semicolon. Now for load bus, we need to solve for B3. B3 is equal to 1 over y 3 comma 3 is 3 q 3 minus I divided by conjugate B3. 3 minus 5 3 1 B1 minus 3 2 3 comma 2 is B2. Now we will set the number of iteration to 3 iteration. So for m is equal to 1, 3. Our last script is to display the results. Display m. This is the number of iteration. Next is to display value of Q2. Next is to display absolute value of Q2 and the angle B2 times 180 divided by pi. This is to convert into degrees. So we need to display also the value of the value of B3 angle B3 by parenthesis. So spacing rotation. This is the end. You need to write the end. Shows Question for voltage is V2. For voltage V3. So I think will be will be completed. So let's try to save it. So we need to Seidel. So let's try to run and let's see what happened. Yes. So we have the results of Q2. It is equal to 0.1485. Voltage V2 is equal to 0.9917, angle 3.3 degrees. So that's it. Thank you.